So dear students, today we are going to solve the test paper which I have provided you on Telegram and also on the WhatsApp group. This was the test paper based on the reflection of light from class 10th CBSE, right? In which I have given you some PYQs, some NCRT exemplar questions and some most important questions which I think they may be asked directly. Okay, so we will solve all the questions one by one. If you haven't attempted the test yet, so it's your duty to stop the video, solve the question, and then see the solution. Okay, so let's first solve the first question. The question says that the image of an object formed by a mirror is real inverted and is of magnification -1. So we are given with the, first of all we will write what is given. So given m is equals to -1, right? Now it is saying if the image is at a distance of 40 centimeter from the mirror. Okay. Now because it's a real and inverted image, so I can say that the mirror will be concave and real and inverted image always formed at the left side of the mirror. So the distance taken would be negative. So I would say V would be -40 centimeter, right? Now it is asking where would be the image be if the object is moved. Okay, first it is asking where is the object placed. So we have to find out U. Okay. So we know that m is equals to minus V upon U for mirror, right? M is given -1. V we also know that it is -40 and U we don't know, right? So definitely from here U would comes out to be -40 centimeter. That means U is also -40 and V is also -40. That means the object is placed at where? Center of curvature. Because when the object is placed at center of curvature, the image also formed at center of curvature of same size but real and inverted. That's why m comes out to be -1. So I can say that the conclusion is object is placed at C, that is center of curvature. If object is placed at C, so I can say that radius of curvature would be 40 centimeter, right? And we know that f is equals to r upon 2. So focal length would be 20 centimeter, right? Okay. So that's what it is saying, that where would the image be if the object is moved 20 centimeter towards the mirror. So initially it was at 40, that means it was at center of curvature. Now as you move it towards the mirror 20 centimeter, it would reach at where? Focus. And if the object is placed at focus, image formed at infinity, right? We know this, right? But we can prove it by mirror formula also. So we have to prove it by mirror formula. So we know that U is equals to -20 now, and F is also -20 centimeter, right? Now we have to find out V. So we know the formula 1 upon U plus 1 upon V equals 1 upon F. We can just put the values 1 upon -20 plus 1 upon V equals 1 upon -20. If you will solve it, 1 upon V will comes out to be 1 upon 20 minus 1 upon 20. That means 1 upon V would be equals to 0. That means V would be equals to infinite. That means image is formed at infinity, right? Also we have to draw the ray diagram. So we can draw the ray diagram like this. Let's suppose this is the concave mirror. Make the mirror properly like this. You have to show the shaded region also, right? Give the name to the mirror. Let's suppose M dash. This is your pole. This is, let's suppose, your focus. This is your center of curvature. You place the object on focus, right? One ray you will pass parallel. It will pass through focus, right? The light which falls parallel to the principal axis, it pass through focus. And second ray, you, if you want, you can pass through pole and draw it parallelly like this. So here also they are parallel. If you extended before, then also they are parallel. That means they are never going to meet, or we will say that they will going to meet at infinite. So this would be the correct ray diagram. Obviously, we would name the object A, B. You can give any name. I just named it A and B. So this would be our complete solution of first question which has been asked in All India CBSE 2016. Right? Okay. Let's move to next question. Now again, pause the video, solve the question, then see the solution. Okay. The question says that the size of image of an object formed by the mirror having a focal length of 20 centimeter is observed to be reduced to 1/3 of its size. Okay, that means first of all it is saying mirror. Okay, so it is given that m is equals to -1/3, right? Okay, now the size is reduced. Okay, great. At what distance the object has been placed from the mirror, and what is the nature of the image and the mirror. Now, in the question, it is saying that the image is formed, whatever image is being formed, it is of lesser size or smaller size than the object. Now, we know that both concave and convex mirror forms the diminished image. That means in the question, it is still not clear that what is the type of mirror, right? So we have to take both the possibilities, that what happens if the mirror is concave and what will happen if the mirror will be convex, right? Okay, so let's take the case first. Case first. Case first would be when the mirror is concave, right? If the mirror is concave, definitely the image will be real and inverted, right? Okay, that's great. So m will be -1/3, right? Okay, and f is given. F is -20. If it would be convex, then f will be +20, m will be +1/3. But now we are taking concave mirror, so m would be -1/3 and f would be -20 centimeter. Okay, that's great. Now we know that m is equals to -v/u. So I can say that -1/3 will be equals to -v/u. So from here, v comes out to be u/3. It is not 4/3, it is u/3, right? Okay. Now we know the mirror formula, 1/v plus 1/u equals 1/f. So v value is u/3. So it will become 3/u, because 1/v is 3/u, because v is u/3, plus 1/u will be equals to 1/f, and f we know it is -20. So this would comes out to be 4/u equals -1/20. So from here I can say u will comes out to be -80 centimeter. Properly you have to write every solution, right? That's why I'm writing each and everything very properly. So u will comes out to be minus 80. So v will comes out to be u by 3, that is minus 80 by 3, minus 80 by 3. No need to solve it. So v is minus 80 by 3 centimeter. Since it is coming negative, I can say that image will be real and inverted. I already declared it here by looking at the value of m, but now I can say it very surely that definitely the image is real and inverted. Okay, this is our case first. Now I'm erasing it. Now if you have understood, solve the case 2 yourself, then see the video. Let's solve the case 2. Now in case 2, if I assume that mirror is convex, then image should be virtual and erect, but now let's prove it. So image would be, let's write it, virtual and erect. Okay, so if magnification is 1 by 3, so m will be equals to plus 1 by 3, right? F will be equals to plus 20, and m we know, m is minus v upon u, that is 1 upon 3. So v would be comes out to be minus u by 3. Now again use the mirror formula, 1 upon v plus 1 upon u equals 1 upon f. So it would comes out to be minus 3 by u plus 1 by u equals 1 by f. So it would comes out to be minus 40 centimeter this time, and v will comes out to be minus 40 by 3, that is plus 40 by 3 centimeter. So because image distances comes out to be positive, that means it is on the right side, and definitely it's a virtual and erect image. So it's a beautiful NCERT exemplar question in which you have to take both the cases into the account. Here, let's move to next question. Again, it's a very great question. You have to first pause the video and then solve the question, then check the solution. Let's see what the question is saying. Question is saying that when an object is placed at a distance of 60 centimeter, okay, so we are given with one object distance, that is 60, from a convex spherical mirror, okay, the magnification produced is 1 by 2. Great. Where should the object be placed to get a magnification of 1 by 3? That means two magnification are given, one object distance is given, and second object distance is being asked from the same mirror. That means the mirror has not been changed. If mirror has not been changed, that means the focal length and the radius of curvature is also not being changed. That means in the first case and in the second case, f would be the same, right? So we get an idea that how to proceed the question. Anyway, let's write what is the data given. So we are given with u1. u1 is minus 60 centimeter. m1 is given plus 1 by 2 because it's a convex mirror. u2 we have to find out. m2 is given, that is plus 1 by 3. This is the given information which I just conveyed to you. Okay. Now we know that for case 1, m1 would be equals to minus v1 upon u1. So V1 would be equals to minus M1 U1, right? M1 we know, M1 is 1 by 2 and U1 is minus 60. So V1 comes out to be 30 centimeter. Now in the case first, we know U, we know V, we can find out F. We can use that F into the second case and then find the U2, right? Now I have given you the enough hint. Now pause the video. Behave like a serious student. Don't see my video like a picture with the popcorn in your hand, right? It will not give you anything. Just solve it. Whether you get all the questions wrong, no problem, but just solve it. Even if you get one way by which we should not solve the question, so at least try once. Okay, so we have got V1. V1 is 30 centimeter. Now you can use the mirror formula. So by using MF, mirror formula, I'm writing in short. You cannot write it like this. You have to write complete by using mirror formula. Mirror formula is 1 upon U1 plus 1 upon V1 equals 1 upon F1, right? So U is what? Minus 60. V is what? 30 equals 1 upon F. So 1 upon 30 minus 1 upon 60 would be 1 upon 60. So 1 upon F will comes out to be 1 upon 60. That means F1 will be comes out to be 60 centimeter. Right? Okay. Now since mirror is same, so F1 will be equals to F2, that is again 60 centimeter. Now again we can apply for second. M2 is equals to minus V2 upon U2 for second case. So V2 will be comes out to be minus U2 by 3, right? Now we don't know U2, no problem. We can again use the mirror formula. So I'm erasing it. So we got V2 is equals to minus U2 upon 3, right? Now again apply the mirror formula. 1 upon F equals 1 upon U plus 1 upon V. F is again what? 60, right? So 1 upon 60 equals 1 upon U2 and V2 is minus U2 by 3. So it will be minus 3 upon U2, right? So from here, we can say that 1 upon 60 will be equals to minus 2 upon U2. So U2 will be comes out to be minus 120 centimeter. This would be our answer. That object should be placed at 120 centimeter from the mirror to the left side so that we got the magnification of plus 1 by 3. Amazing question, right? Learn the way I'm solving the question. Then only you will get the benefit. Next question, CBSE 2015. Again, pause the video, write the solution yourself, then check the video. Question is saying, a student has focused the image of candle flame on a white screen using a concave mirror. Okay. The situation is as given below. Length of the flame is 1.5 centimeter. Okay. So we are given height of the object, right? That means H1 is given plus 1.5 centimeter. This I am writing what is given, right? Second, focal length of the mirror is given. F is given minus 12 centimeter because mirror is concave. Distance of flame from the mirror, okay, U is given minus 18 centimeter. Fine. If the flame is perpendicular to the principal axis of the mirror, okay, that's great. Then calculate the following. Distance of image from the mirror, V is being asked. length of the image. That means h2 is being asked. And that's not enough. They are asking if the distance between the mirror and the flame is reduced to 10 centimeter. Now the same case which we have discussed, right? Then what would be the observed on the screen? Okay, draw a diagram to justify your answer for this situation. It's a 5-mark question. They have squeezed you like a lemon, right? Okay, let's see. So to find v, let's put mirror formula. So 1 upon u plus 1 upon v equals 1 upon f. 1 upon u minus 1 upon 18 plus 1 upon v, we don't know. 1 upon f is minus 1 upon 12. Well, let's take a LCM. 1 upon v would be equals to 1 upon 12 minus 1 upon 12 plus 1 upon 18, right? LCM would be 36 minus 3 plus 2. It would be minus 1 upon 36. That means v comes out to be minus 36 centimeter. Put the units also. Okay. Now we have to find h2, that is height of image. So we know that m is equals to minus v upon u equals to h2 upon h1, right? So h2 would comes out to be minus v upon u into h1 minus v. So minus 36 minus 18 into 1.5 comes out to be minus 3 centimeter. It is clearly visible that image is magnified and value is negative. That means it's a real and inverted image, right? Okay. Now look at it carefully. F comes out to be, F is minus 12, right? And U was 18 centimeter. Look at it carefully. Now, if it is saying that if the distance between the mirror and the flame is reduced to 10 centimeter, that means now the object is placed somewhere between pole and focus, because focal length is 12 and you are keeping the object at 10 centimeter. That means you are keeping the object between pole and focus. And the object, if object is placed at between pole and focus, you know that image formed would be virtual behind the mirror. And in the question they are asking what could be observed on the screen, you will say nothing will be observed on the screen because the image would be virtual and erect, and you can show it with the diagram also. That let's suppose an object is placed like this. First ray you will pass like this, it will pass through focus, and second, if you want, you can pass it through the center of curvature. If you extend it before in front of the mirror, you will look at it like this. And since you are making the virtual image, make it with the dot dot pattern. Don't make it with the solid line. If you will give the name A and B, the image would be A dash and B dash. This is the complete ray diagram, right? I'm showing you each and everything so that there should be no confusion. This is our complete solution of this question. Let's move to next question. It is also a nice question. A concave mirror of focal length f, okay, produces an image n times the size of the object. That means m is given minus n, right? Which will be equals to minus v upon u. Okay. What would be the object distance for which the image is real? Okay. Well, we can cancel the negative. N would be equals to v upon u. Well, we can put the mirror formula 1 upon u plus 1 upon v would be equals to 1 upon f, right? Uh, you can use v is equals to, we have to find what? Object distance, na? So just take v in terms of u. V is equals to nu, right? So 1 upon u plus 1 upon nu equals 1 upon f, right? Now you have to find u, na? So you can take u common. So it would be 1 plus 1 upon n will be equals to 1 upon f, right? And it would be 1 upon u, n plus 1 upon n is equals to 1 upon f. So u comes out to be n plus 1 upon n into, this would be your answer. Let's move to next question, that is CBSE 2016. It looks horrible. Actually, it is easy. Look at the question carefully and try to solve it. Question is saying, suppose you are having three concave mirrors A, B and C of focal length 10, 15 and 20 centimeter. Okay. So first of all, what is given? We are given three mirror having focal length 10 centimeter, 15 centimeter and 20 centimeter. For each concave mirror, you perform the experiment of image formation for three values of object distance. Okay, that means U1 is given 10 centimeter. I'm not putting any sign for now. If we need to apply into the formula, then we will put it with the sign. For now, I'm just writing the values which are given, right? So three concave mirror of focal lengths are given, and for each concave mirror, you perform the experiment of image formation for three values of object distance. Giving reason, answer the following. Okay, let's see the question. For the three object distances, identify the mirrors or mirror which will form an image of magnification minus 1. Okay. Now, if you are getting the, whenever you just solve the question, don't get afraid of the question. Whatever you know, just write it. Like for example, when I got that m is equals to minus 1, first picture will comes into my mind that f, the m value is 1. That means the object should be placed at where? Center of curvature. Because m1 means we are getting the image of same size as the object, right? That means u should be equals to 2f. U should be equals to 2f, right? So you can say that for mirror A, it would be u2 because 10 centimeter is the focal length and object is placed at 20 centimeter. That means it is placed at center of curvature. And for mirror B, it will be u3, right? So two answers are there. For A, it will be u2 and for B, it will be u3. This is our first answer for question number 1. Let's check question number 2. Out of the three mirrors, identify the mirror which would be preferred to be used for shaving purpose or makeup, right? Now we have already done this, that for shaving purpose and for makeup, we want the magnified image. That means object should be placed between pole and focus, right? It should not be at focus, it should not be beyond focus, it should be between pole and focus. right? So if you will check that mm, out of the three mirror, identify which would be preferred to be used for shaving purpose and makeup. Okay. Mm, but in this case, all the mirrors are given, all the image distance are given, object distance beyond focal length. Well, okay, fine. So, out of the three mirrors, identify the mirror which would be preferred to be used for shaving purpose and makeup. You are having three distances, na? Okay. So, for U1 distance, check for U1 distance. You cannot use FA, right? You can use FB because object distance is at 10 centimeter and focal length is 15. So, that means you are already between focus and pole, right? You can use FC also. That means you can use mirror B and mirror C. Both can be used. Okay. For U2, you cannot use A, you cannot use B, you cannot use C. And for U3 also, you cannot use A, B, and C. Because in every case, you are either at focus or beyond focus. We want you to be between focus and pole. So, for U1 distance, you can use B and C mirror. Right? Clear. Now, third, for the mirror B, draw the ray diagram for image formation for object distance 10 centimeter and 20 centimeter. Now you can make it very clearly, I think. Let's make it. So for mirror B it is saying, right? So for mirror B, focal length is 15 centimeter and U it is saying 10 centimeter. So that means they want us to draw the diagram this one. So we have already draw it. So no need to draw it again. I have clearly shown it here. You can just copy it from here, right? Second, it is saying when the object is placed at 20 centimeter, right? Now, if it is placed at 20 centimeter, that means it is placed between focus and center of curvature. That means image will be formed beyond center of curvature. Let's try to draw it. So image will be like this. If object is AB, it will be B dash A dash, right? Clearly mark the ray diagram M, M dash, this is P. Now it is complete, right? Again, it's a great question. I deliberately just pick the great questions only, right? Because I can just show you the easy question and give you the fake confidence also, right? There is nothing use of it, right? When you will sit in the exam, you will going to abuse me only, right? So just abuse me now, hate me now, and solve this question so that you can wish me good in the exam. Let's solve two more questions. It's a simple question. State two position in which a concave mirror produce a magnified image of a object. List two difference between two images. So two case you can take. One case between pole and focus, and second you can take between focus and center of curvature. And what would be the difference? In both the case you will get the magnified image, but here you will get virtual and erect image, here you will get real and inverted image, right? So two difference: virtual, real, erect, inverted. Next question: an object is placed at a distance of 12 centimeter in front of a concave mirror of radius of curvature 30. If radius of curvature is 30, focal length would be 15, and object distance is 12. That means it is between pole and focus, it is somewhere here. So what type of image would be formed? It would be virtual, erect, enlarged, and laterally inverted. So this will be the four characteristics: virtual, erect, enlarged, and laterally inverted. Next question: CBSE Delhi 2015. Let's try to solve it. Question is saying, to construct a ray diagram we use two rays of light which are so chosen that it is easy to determine their direction after reflection from the mirror. Time pass. Choose these two rays and state the path of these rays after reflection from a concave mirror. Again time pass. Use these two rays to find the nature and position of image of an object placed at a distance of 15 centimeter. U is minus 15 centimeter and F is minus 10 centimeter. That's all. That means object is placed between focus and center of curvature. That means they want us to make this diagram again, right? So we have already done this, but you have to draw it again. Don't show the laziness. And we can find out the V. So V would be 1 upon V, 1 upon U plus 1 upon V would be 1 upon F. Now I am not writing the properly the solution, because I have shown you 2-3 questions. You have to draw it properly, write the what is given, what is being asked. We know that mirror formula is this, then solve. So 1 upon V would be 1 upon F minus 1 upon U. Right? Anything is asked? Choose these two rays, state the word, use this to find the nature. Nature is being asked. Okay. So nature will be, we can find out m is equals to minus V upon U. So minus 30 upon minus 15, it would comes out to be minus 2. Minus 2 means, minus means real and inverted, and since the value is greater than 1, so it will be enlarged, right? Ray diagram we have already done it. Next question, again CBSE 2015. Question is saying, a student wants to project the image of a candle flame on a screen 80 centimeter in front of a mirror by keeping the candle flame at a distance of 20 centimeter from its pole. Okay, so U is given. U is minus 20 centimeter, and V is also given. It is on the screen, so that means it's a real and inverted. That means it would be on the left side. So I'm taking V as minus 80 centimeter. Right? Listen me very carefully. Why I'm taking minus plus, because everything is just based on this minus plus only. If you will take the plus 80, everything would be wrong. So what type of mirror should the student use? Obviously it's a concave mirror. Find the magnification of the image produced. So m will be equals to minus 80 upon minus 20. Magnification would be minus 4. Right? Distance between object and its image. So let's suppose this is a concave mirror. Object is placed somewhere here at 20 distance. Image is being formed here somewhere at 80 centimeter. So the distance between object and image is 60 centimeter. Distance never taken as negative positive, right? It is always positive. Don't do like this that okay, it is minus 20, it is minus 80, so it would be 100. No, right? Use your brain. They are asking the distance between object and the image. It's a 60 centimeter sure shot, right? No plus, no minus. So third answer is also clear. Draw the ray diagram. So again the ray diagram would be same when the object is placed between focus and center of curvature. Simple question, 5 mark question. Next, it is desired to obtain an erect image of an object using concave mirror of focal length 12 centimeter, right? You want to make a erect image. So where should be the what should be the range of the distance of the object placed in front of a mirror? So you can place anywhere between pole and focus. So range would be 0 to 12 centimeter, right? Obviously 0 and 12 should not be included. So you will write between 0 to 12 centimeter. Will the image be smaller or larger than the object? Obviously it would be the larger. Ray diagram we have already drawn it here, right? This would be the ray diagram. Now it is saying where will the image of this object be if it is placed 24 centimeter of the mirror. Focal length is 12. We are placing at 24. That means we are placing at center of curvature. So image will also form at center of curvature. Let's draw the ray diagram. See, I can show you the picture from the book also of the ray diagram. Mostly teachers do that. But I just want to give you the motivation that if I'm drawing, at least show some respect and draw it yourself. Focus is here, center of curvature is here. You are keeping the object here. So definitely image will also be here. So first draw the image. Now we will just by hook and crook pass our line from the this point only like this, and second you can draw like this. This is pole M M dash. If the object is AB, image would be B dash A dash, right? This would be the ray diagram. Next question. Question is saying a concave mirror produce 3 times magnified image on the screen. Okay. If the object is placed 20 centimeter, how far is the screen from the object? So U is given, M is given. We know that M is equals to minus B upon U. So minus 3 would be equals to minus V upon minus 20. So minus minus would be cancelled. V comes out to be minus 60 centimeter. That's all. If the object is placed 20, how far is the screen from the object? Read the question carefully. It is asking the image distance from the object. So object is at 20 centimeter, image is at 60. So distance between object and image would be 40 centimeter. This would be your answer. Next question. Now pause the video, solve it yourself. An object 4 centimeter in height, very good, h1 is given, 4 centimeter, is placed at a 15 centimeter, u is given, minus 15 centimeter. Oh, definitely they are asking. F is also given, minus 10. They are asking v and they are asking H2. I think now you would be able to do it. We have done one question like this. Pause the video, do it. I'm also solving for you. V would comes out to be minus 30 centimeter. Now H2 upon H1 would be minus V upon U. So H2 will comes out to be minus V upon U into H1. Minus 30 minus 15 into 4 minus 8 centimeter. One minus is also here, right? It's a simple question. I just directly solve it. I didn't explain anything. Okay, so that's all for today. It's not that's all. We have done enough practice, right? Now I will come with the second session also, in which we will solve some more latest question related to reflection. Then we will solve the refraction part also. But for now, today, this is all from my side. Revise the concept very properly, solve the question very carefully because it's a easy topic, but it's a highly weightage topic. Okay, so see you in next class. Till then, take care and keep studying.